Alright guys, so in this lecture we're going to be going over coterminal angles. What are coterminal angles? Well, they're angles that have the same initial side and terminal sides, but they have different rotations from each other. So what do I mean? So right here we have an angle measured at 45 degrees. So that means I started at the x-axis and I moved up until I hit my ray, and I've created this little angle of 45. Right? Simple enough. Now let's look at the one right next to him. This one says 405 degrees. Well, let's look at this guy and this guy. The rays are actually in the same exact position. How do I know that? Because I copy and pasted. They're in the same position, but they have different angle measures. So how did that happen? Well, in our first example, 45 degrees, what he did was he started at the x-axis, went to the ray. For 405 degrees, what he did was he started at the x-axis, he passed our ray, went one full circle, and then went to this ending position. So do you see the difference? One went up 45 degrees, one made one full rotation before they went up 45 degrees. Well, one full rotation is 360 degrees. So 360 degrees plus 45 degrees is what? 405 degrees. See how that works? All right, so let's look at another one. This guy says he traveled 765 degrees. So what does that mean? He started at the x-axis. He made one full revolution of 360 degrees. And then he made another rotation of 720 degrees before he went up an extra 45 degrees again. So what's 360 plus 360 plus 45 degrees? Well, it's 765 degrees. Okay, so lastly, we have this guy, minus 315 degrees. So what happened here? So the guy we started at the x-axis, and this time he went the opposite direction. See, anytime we rotate clockwise, our angle becomes negative. So he went the opposite direction, minus 315 degrees. Notice how all the other examples were positive because they were rotating counterclockwise. If you rotate clockwise, your angle measure becomes negative. So this is saying that 45 degrees, 405 degrees, 765 degrees, and minus 315 degrees will have you stop at the same position. Your terminal side will all stop in the same exact spot, even though all these angle measures are different. And this is what it means to be coterminal. It means that the positioning of the terminal side is the same, but the angle measure is different. So how do we go about finding coterminal angles? Well, as we saw in the above statement, coterminal angles are just some angle plus one rotation or minus a rotation. How do we talk about rotations? Well, it's either 360 degrees or it's 2 pi radians, right? So one revolution counterclockwise is 360 degrees or 2 pi radians. One revolution clockwise, this way, is minus 360 degrees or minus 2 pi. Okay, because anytime we move clockwise, our angle becomes negative. Alrighty, so let's do some examples. Alright, our first example, find a positive angle less than 360 degrees that is coterminal to 420 degrees. So we have an angle measure that's 420 degrees, and we want it to be less than 360 degrees. So what do? Well, we already said that coterminal angles are some revolution away from our original angle. So what I'm going to do is I'm going to take away one revolution. If I take away one revolution, that means I'm taking away 360 degrees. So my coterminal angle here is 60 degrees. Not bad, right? Here's the next one. Find a positive angle greater than 360 degrees that is coterminal to negative 45 degrees. So I start at minus 45 degrees. So maybe I'll draw you a little picture. I start at minus 45 degrees. And what I want to do is I want to get to positive, some angle measure that's greater than 360 degrees. So what do? I have to rotate counterclockwise enough times so that my angle measure is greater than 360 degrees. So let's start adding revolutions to minus 45. So here's the first one. I add 360 degrees and I end up getting 315 degrees. But here's the problem. 315 degrees is not greater than 360 degrees. So guess what we do? We just add another revolution. If we add another revolution, that's the same thing as saying we add another 360 degrees. And thus, we finally get to our final answer, which is 675. All right, this one is a little bit more complicated because we're dealing with radians. Radians are challenging because, well, we don't really use them too much in everyday life. And guess what always pops up? Fractions, okay? So our goal here is to find a coterminal angle to 17 pi over 6. So why don't we think about 17 pi over 6 like this first, okay? Let me switch to a highlighter real quick, and let's scoot down. 17 pi over 6 is the same as saying that I have 17 pi over 6's. So if you count all these squares, or rectangles, you'll count 17 of them. So you have 17 pi over 6's. This is what this picture is this number is representing. Now what I want you to think about is this. If I have pi over 6, 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 this row right here, if I add this row together, what do I get? Well, if I add this row, I get pi. If I have 6 pi over 6's, that means I have a pi, right? So this whole thing adds up to pi. And again, if I add the second row of pi over 6's, I get another pi. And then lastly, I have 5 pi over 6's. So another way of writing 17 pi over 6 is also saying that I have this guy plus this guy plus this guy. So another way of saying 17 pi over 6 is saying that I have 2 pi plus 5 pi over 6's. Agreed? So then if I try to find a coterminal angle, I just have to take away 2 pi radians. So the coterminal angle is saying take 17 pi over 6, which is described like this, and take away 2 pi. So what is our coterminal angle then? It's just the leftover. The leftover is this. This is the coterminal angle. 5 pi over 6. So how do we express this algebraically though? So we have 17 pi over 6, and I got to take away 1 revolution. Taking away 1 revolution in radians is me taking away 2 pi radians. Now here's a problem with fractions. I can't just subtract fractions like this, right? I need what? Common denominators. So what I do is I multiply the numerator and the denominator by 6. I got to find common denominators on the right-hand side. So what's 2 pi times 6 divided by 6? Well, it's 12 pi over 6. Once I get common denominators, I can combine the fraction. I keep the denominators the same, which are 6, but I combine the numerators. So in the numerator, I'll have 17 pi minus 12 pi, all divided by 1/6. So it's going to look like this. So what's 17 pi minus 12 pi? Just pretend pi is like a variable x. what's 17x minus 12x? 5x, right? So therefore, if I have 17 pi minus 12 pi, I have 5 pi over 6. So you see, what we did first was we drew it and we came to a conclusion just via drawing. And then we had to show it algebraically. Of course, on an exam or whatever, you don't have to do this part. You just have to do it algebraically. Okay, let's do another one. Find a positive angle less than 2 pi and greater than 0 radians that is coterminal to minus pi over 12. So I have minus pi over 12. Obviously, this angle measure is negative, and I need to be greater than 0. So let's start adding 2 pi's to it. Let's add 1 revolution. So I have minus pi over 12 plus 2 pi. I got to get common denominators again. So multiply top and bottom by 12. 2 pi times 12 is 24 pi. So I have minus pi over 12 plus 24 pi over 12. Combine the numerators and make one huge denominator. So 24 pi minus 1 pi is 23 pi divided by 12. So this is pretty much almost exactly like what we just did in the previous example. So here's our last example. Find a positive angle less than 2 pi that is coterminal to 22 pi over 4. So I'm going to do the same thing that I did with the last example, which was, I'm going to draw it out first. Maybe not the last example, but 2 examples ago. So right here, I have 22 pi over 4s. Okay, so we're going to attack this the same way as before. Remember, if I add 4 pi over 4s together, what does that add up to? It adds up to pi. So guess what? Each one of these rows add up to pi. So how many pi's do I have at the end? Well, I have 1, 2, 3, 4, 5. This means that another way of expressing 22 pi over 4 is saying that I have 1, 2, 3, 4, 5. I have 5 pi plus my remaining, which is 2 pi over 4. I have 2 pi over 4s. So what would be my coterminal angle? My coterminal angle would be taking away as many 2 pi's that I can. So here's 1 2 pi, right? These two columns, these two rows add up to 2 pi. And then these 2 rows add up to 2 pi. So that means I could take away 2 revolutions. I could take away 4 pi. If I take this statement up here, and I take away 4 pi from it, what am I left with? I'm left with pi plus 2 pi over 4. So my resulting angle measure will be this row plus the last row. Pi plus 2 pi over 4s. So this will be my coterminal angle if I add these two together. So how do I show this algebraically? Well, I have 22 pi over 4, and I take away from it these 2 revolutions. So 2 revolutions is 4 pi. Each revolution is 2 pi, so 2 revolutions is 4 pi. So I have 22 pi over 4 minus 4 pi. Subtracting fractions, first thing we should do is get common denominators. This guy is 4, so let's multiply both guys, top and bottom, by 4, so we have common denominators. Once we get common denominators, we can combine the numerators, so I have 22 pi minus 16 pi, and I can just get one huge 4 on the bottom. So I get 6 pi over 4. And, oh, I didn't simplify it. Well, 6 pi over 4, what does that reduce down to? 3 pi over 2.